In this video we're going to look at how we can use the remainder theorem to find the remainder when a polynomial is divided by a linear expression. Now this is very similar to the factor theorem in terms of how we do it in practice. So if x plus 5 was a factor, then f of negative 5, which is what's required to make this equal to 0, the value of that would be 0. Now the remainder theorem, the only difference is instead of it being 0, because we know it's not a factor, whatever number we actually get is just what the remainder is. So I'm going to write this as a factor, so I'm going to say, as a function, so I'm going to say let fx be 3x cubed subtract 4x squared subtract 2x plus 6, and I'm going to evaluate here f of negative 5. So 3 lots of negative 5 cubed, subtract 4 lots of negative 5 squared, subtract 2 lots of negative 5, add 6. So I'm going to evaluate this using my calculator. So 3 multiplied by negative 5 cubed, subtract 4 lots of negative 5 squared, subtract 2 lots of negative 5, add 6, and that's given me here negative, I don't know if you can see that, but that's given me negative 459. So therefore the remainder is negative 459. So if I look at this second one, I'm going to go through the same process again. So I'm going to define my polynomial as a function of x, so let fx be 2x cubed add 4x subtract 2. So what am I going to evaluate here? Well, I need this to be equal to 0. So if 2x minus 3 is equal to 0, then 2x is equal to 3 and x is equal to 3 over 2. So it's f of 3 over 2 that I wish to evaluate. So that's 2 lots of 3 over 2 cubed and 4 lots of 3 over 2, subtract 2. So I'm going to type that into my calculator. So that's 2 multiplied by 3 over 2 cubed, add 4 multiplied by 3 over 2, subtract 2. And we can hopefully see that as 43 over 4. Or I could, if I want to, just hit this button here and I could have my answer as a decimal, which is then 10.75. So therefore the remainder is 10.75.